Welcome to our ASL alphabet model, visual detection model. Here's a brief outline of what we will be discussing today. Our core goal for this project was to promote curiosity for American Sign Language by giving beginners a fun and accessible way of practicing ASL. We hope that this project would generate interest in American Sign Language and enhance visibility for those who communicate with ASL. Our second goal was to train a model to recognize the American Sign Language alphabet with at least 80% accuracy. From the onset of our project, we realized that our data would have to be high quality, especially because many signals such as M and H and G and H could be easily mistaken for each other. The first phase of our project involved gathering several thousand images with at least 200 examples of each letter of the alphabet to train our model with. We used several existing databases that contain images of the ASL alphabet, as well as using our own cameras to take pictures of us modeling these signals.
I think you might be muted.
We can't hear you, Diego.
Can you hear me?
Okay, yeah, there you go. All
Sorry.
good.
Sorry about that.
All good.
So the way we went about making this is we first amassed, as previously mentioned, over 6,700 images with a bunch of our own included for increased variance. We annotated and labeled this using the tool RoboFlow, which streamlined the process, made organizing our data much easier, and also simplified the exporting process. And we needed to import it into the model that we chose, YOLO V8. We specifically chose this model for its speed and accuracy, as well as ability to be embedded inside of the website, which made the live image annotation possible. There were a total of 26 classes for each of the 26 letters, and we augmented our data utilizing horizontal flipping, exposure, brightness, and noise. As for our web stack, the front end was built in SvelteKit TypeScript CSS. Our back end had the model deployed onto Hugging Face Space, and we use a Flask server as a proxy for communication between the two.
As for our challenges, our model was overfitted because we sourced most of our data from online repositories. The images had diverse backgrounds, but none of them included faces, so the model often recognized them as ASL letters. As you can see on the left, our old model recognizes this man's face as an N. To fix this, we added several hundred images that include faces. Certain angles also presented challenges for the AI, which we dealt with in a similar manner, which is adding more data. And next, some of our online sources included ISL or Italian Sign Language gestures in their data sets, so we had to manually remove these images. And finally, we had many disconnections on Google Colab while we were trying to train our model. On top of this, the monetized GPU usage limit, which we hit several times due to the disconnections, forced us to create alternate accounts or develop the model locally.
Once we overcame these challenges and had our model trained, we had to evaluate it. Some tools that we used included different graphs and summaries of the results. For instance, as you can see in the top left, the p-curve showed the relation between the model's confidence and its precision. Our model had both variables increasing simultaneously, which was good since we don't want an overconfident model making inaccurate predictions. We also looked at the precision recall curve. It showed the trade-offs between the false positives, which is when something is predicted as true when it is not, and false negatives. It would have been most desirable to have both precision and recall be high, but there was definitely a trade-off. As Stephen mentioned before, our original accuracy goal was 80%, and once we calculated the mean of the normalized confusion matrix's trace, we ended up with 93.4%, which is a very good sign. The result of these evaluations allowed us to minimize loss and achieve high precision.
Now let's watch a trailer video of our project.
Hello, and welcome to the ASL Detector. Our team wanted to make American Sign Language more accessible to beginners. We developed an AI model so that anyone can practice signing the ASL alphabet. On average, our model can predict any letter of the ASL alphabet in real time with 93% accuracy.
The ASL detection tool can be found on our website, which is in the description. Come to the website and try it out. Thanks for watching, and be sure to like and subscribe.
All right, as you saw, we do have a website with a live camera demo, and one of our team members are going to paste this link into the chat for you to visit yourself. But here it is. We have our overview with our upload media buttons from a file powered by the backend or the live camera, which is running directly in the browser. We have our About Us section stating our goals, and we have our team section stating the people that worked on this and their intros, what interests them. And we also have our evaluation section, which shows the data that we collected through training our model through 100 epochs. And as you can see, we're able to run it directly in the browser. And that's it for our presentation. Does anybody have any questions?